This is a brief addendum video for the Route to the Band of Stability lab to describe how do you determine what decay mode you might have for a radioisotope if it's not on table N. So here's the lab. If you scroll down to this highlighted section here that says use the band of stability chart in this slideshow to determine the route to stability. Open that up. And then you'll see this chart. The blue dots on this chart are all stable isotopes. So very briefly, if your isotope, your unstable radioisotope, has more neutrons than the stable version of that isotope, more neutrons, then it's beta decay. If your stable isotope has less neutrons than, if your unstable isotope has less neutrons than the stable isotope, it's positron or electron capture. And then if you have a radioisotope that has 83 or higher, so greater than 82 protons, then it's alpha decay. So all these up here are alpha decay. Let me give you an example. So from the Band of Stability lab, I previously mentioned that you need to open up this Band of Stability graphing sheet and fill in the column C through H. Column H will only be filled in for the unstable radioisotopes. So an example is here for C12, 14, and helium-4. Okay, so let's take C14 for an example. C14, you can actually look this up on table N, but if I didn't have table N, how could I figure this out? So C14 has 6 protons and 8 neutrons, right? So I'm going to go to this band of stability graph here. I'm going to blow it up, zoom in a couple of times. See if I could do this. Okay. And if I have 6 protons and 6 neutrons, that's stable. But if I have 8 neutrons and 6 protons, 8's going to be above here. The neutrons are on the y-axis, so 8 neutrons is going to be above. So this is beta decay. So if I have more neutrons than the stable isotope, it's beta decay. And then if I had less neutrons than the stable isotope, it is a positron decay. Usually, sometimes electron capture. You could use either one and they'll be acceptable. So let's just look at this for an example. Look at this one. This red dot is, I think that might be iron. But anyway, it's the radioisotope is the red dot here. The blue dots above it are the stable isotopes of that element. So everything in a vertical line is the same element. So this red dot is unstable. The blue dots are stable. So the red dot, what kind of decay would that isotope have? Well, it has less or fewer neutrons than the stable isotopes do, fewer neutrons. So therefore, positron decay. Okay. And if I had a radioisotope that was up here with more neutrons than the stable isotopes, then it would be beta decay. All right, so I can use the graph. I can zoom in and use the graph if I want. Or another method is to click on this link here to open up the spreadsheet itself that I use to actually make the graph. And it always, I don't know, always comes over here. So you have to like scooch it over. Find the element. I think I was looking at element 14 before, right? That's the one that we saw the red dot on there. Okay, if I have, so element 14, the stable isotopes have 14, 15, and 16 neutrons. This is the proton column, neutron column, with a mass number of 28, 29, and 30. So if I have a isotope with 14 protons and 32 mass number, or 18 neutrons, that would be, right? Then I have more neutrons than the stable isotopes. So my dot would be above the blue dots and it would be a beta. So if you don't want to like zoom in to this chart, you can just look it up per the numbers. Again, more neutrons than the stable isotopes, beta decay. Fewer neutrons than the stable isotopes is positron decay. I think the one I did with you guys was carbon, right? Stable isotopes for carbon are 12 and 13, carbon 12 and 13. So carbon 14 has more neutrons, so it's beta decay. If I created a carbon 11, it would be a positron decay. So how can you remember that? This chart tells you beta decay is above, positron decay is below, alpha decay is big atoms with more than 82 protons. That same type of graph, I clipped it from someplace and it's right here also. Okay, that's the end.